Alright, I said I would talk about those change in velocity problems, and that's what we're going to do. We're going to talk about the two things that I'm asking you to do with vectors. Okay. One of them is to find the change in a quantity. Okay. When we do a change in a quantity, whether we're talking about change in displacement, that's going to be my final position minus my initial position, or change in velocity. Those are really the two that we're looking at right now. So final velocity minus initial velocity. When I'm looking at the change in a quantity, I am subtracting two vectors. That's something that's important to keep in mind as we go through this, because when we do something like find the resultant, when we find the resultant of two vectors, we are adding stuff together. This is adding vectors. The resultant vector is usually my delta x plus my delta y. Okay? So finding the resultant is adding things together. Looking at the change in a quantity is subtracting two things. And it's subtracting two things that kind of gets us caught up on stuff. So the first question is saying we start off with an initial velocity of 20 meters per second to the east, and we end up with a final velocity of 20 meters per second south. There are about 18 different ways to explain this. I'm going to show you the two that I think are the most clear, and the one where your error usually ends up being. So the first way to explain doing this, just looking at it, change in velocity is equal to final velocity minus initial velocity. For the quantities we have, the change in velocity is going to be the final velocity, 20 meters per second south, minus the initial velocity, 20 meters per second east. Now, when we're looking at this, we can't just say 20 minus 20 is 0. That's not allowed. Because I can't just add something that's south and add something that's east. It doesn't work that way. I have to do that weird triangle math when we do things like that. But I don't know how to do triangle math with subtraction. And when we talk about a negative sign, it just means an opposite. So really, I want the opposite of 20 meters per second east. So a better way to write this would be 20 meters per second south plus 20 meters per second west. Because I took the opposite of 20 meters per second east. I did what that negative sign told me to do. Now, these are vectors. I can't just add those together and get 40. I have to do the triangle thing, which means I have to go 20 meters per second south and then 20 meters per second west. At this point, I can find my resultant. So the resultant here is the square root of 20 squared plus 20 squared. It's something close to 28. And this angle, since they're the same, we know is 45 degrees. And when we say the answer to this is 28 meters per second at 45 degrees, and for this triangle we start off south, we swing a little west, so it's west of south. Okay, that's the first way to do it, is just look at the change in velocity formula. The second way that I want us to kind of look at this is to pictorially look at what's happening. So here's our second explanation. With our second explanation, we begin with a velocity of 20 meters per second to the east. So I'm just going to give a quick sketch of that, right? My vector is 20 meters per second, points in the easterly direction. And as time goes on, it's going to end up being 20 meters per second south. Now what I want to do is look at what it's going to take. What are the things that I have to do to my velocity to get from 20 meters per second east to 20 meters per second south? Now, if we look at the end here, I don't see any velocity to the east or to the west. So, if we imagine somewhere in the middle, we're going to have to completely stop our motion. We're going to break it up into smaller parts, basically. So we're doing two things. We are, one, completely stopping our motion, and two, giving ourselves a motion in the southerly direction. So if I want to completely stop my motion, I have to add 20 meters per second west. Doing that, changing my velocity by adding 20 meters per second west, is going to give me a zero velocity in the x direction. So that's the first thing I have to do. Now, once I'm at zero, I want to go south. So then I have to add 20 meters per second south. So if we look at the two things we did to change our velocity, one of them was 20 meters per second west, one of them was 20 meters per second south. And this is what I got, which is, again, the 28 meters per second at 45 degrees. And looking at it again, this one is a little bit different. It's south of west. Either way, it's still south and west. Those are the two ways I want us to look at these problems. Okay. We will come back to finding the resultant at the end a little bit, but that's what we've been doing the whole time. So for the second problem, okay, it said we had an initial velocity of 60 meters per second north. So that's my initial velocity. And my final velocity ended up being 60 meters per second south. Okay. So again, the easiest way for me to visualize this problem is to say my change in velocity for that motion is my final velocity minus my initial velocity. So my change in velocity is 60 meters per second south minus 60 meters per second north. Now, 60 minus 60 is 0, but 60 south minus 60 north is not. And the reason it's not is because of our little negative sign right here. That does something to this entire vector. So really what this is, what I'm saying, is my change in velocity is 60 meters per second south plus 60 meters per second, I did that wrong, plus 60 meters per second south. This negative sign right here changes that north to south. So my change in velocity in this case is 120 meters per second south. That's my change in velocity. The other way we can think of this is, all right, initially we started with 60 meters per second north. We did some stuff and we ended up with 60 meters per second south. Somewhere in the middle we know we had to stop. So the things that we did here to get from 60 north to 60 south, well, in order to stop, to get a velocity of 0, I have to add to my vector, oh, that's an awful looking line. I have to add to my original vector one that points in the opposite direction, which is 60 south. That's going to bring me to a stop. Then the next thing is to go from stop to 60 south. That is 2 moves that are 60 meters per second south, giving me a total of the things that I had to do to change of 120 meters per second south. Now, something that was a little confusing today was finding the resultant. All that finding the resultant is adding vectors. When I say I'm going to find the resultant velocity, that means I am going to add the velocity in the x to the velocity in the y. When I say that I'm going to find the resultant displacement between two vectors, it means I'm going to add those two vectors together. And we spent the whole beginning of this week talking about how to add these things together. So I'm going to leave it at that.